So, welcome once again. Let us start with the topic which we started yesterday, coordination compounds. Today we'll complete the naming of coordination compound. This question is quite important. One nomenclature, IUPAC nomenclature, worth of 1 or 2 marks will be definitely there in the board exams or even any entrance exams as well. So let us go through few rules first of the IUPAC naming of coordination compound. Okay, before we start any naming for the coordination compound, it is must to identify whether the complex is cationic or anionic. Okay, first we have to identify whether the complex is cationic or anionic, because the namings will vary as per the charge on the complex entity. Fine. The first rule identifies the cation and anionic complex. Now, how to name them? The ligands which are there, the one which ends like chloride, so the name of chloride, that is, chloride can be converted to chlorido. So IDE, any negative anion ends with IDE, needs to be replaced with O. So we have bromide here, so the name will be bromido. Chloride, chlorido, okay, oxide, oxo, ate, like sulfate, nitrate, the suffix will get changed to ato, like sulfate, sulfato, ite, nitrite or sulfite will change to ito. This we have to. The basis of that, these are a few examples of the ligands that are named here: bromide, bromido, chloride, chlorido, oxo, hydroxo, cyano, oxalato. Oxalate ion is oxalate, ATE. So oxalato, carbonate, carbonato. This is acetate, ATE. So it is ATO, acetato. Amine, these are neutral ligands. Amine, amine. Aqua, nitrosyl, carbonyl, dioxygen, dinitrogen, pyridine, and ethylene diamine. These are the three neutral ligands. The negative ligands have the charge on them -1, -2 oxalato, oxalate, oxo, oxalato -2, carbonato -2. We also use the prefix. Say, for example, if we are having more than one same type of ligand, we use the word di or tri or tetra. But in case of the ligands which already say for having this numbering, say for example, the name like ethylene diamine, this word di is already there in the name of the ligand itself. So suppose if we are having a metal with ethylene diamine 2 times, and can be written as, I cannot write diethylene diamine, diamine, because di is already there in the name of the ligand. So I cannot use di 2 times. In case of that, and this nomenclature is already used, what we do is, instead of writing di, we write bis. Okay, it's 3 times. Because ethylene di word is already used in the names of ligand, we write tris, tetra. Okay, like that, di, tris, tetra. Yes. Okay, like this, we have to rename the number of the ligand instead of writing mono, di, tri. It is only when the mono, di, tri is already there in the name of the ligand. Now here, let us talk about few. If the complex ion is cation, then what we will do? Okay, so if the complex ion, complex entity, that is the metal ligand is cation, the complex entity is positive, the name of the metal will remain as it is. Suppose here, if the metal is iron, we'll use the word iron only, not rename. If it is platinum, we'll use the word platinum. So name of the metal ion will not change, it will remain the same. But in case of anionic, metal and there is a negative charge. And in that case, the metal name will change, will be changed with suffix A. Like suppose if I have iron, so iron will use a Latin name farad. If it's copper, right? Cuprate. Lead, with the Latin flavate, argentate, aurate, tannate. Okay, like this. So for anions, we'll be using the suffix with ate and their Latin name if they are having any Latin. Let us now solve two examples. Say for example here. Now how we will name this complex? Okay. So let us first identify this as an anionic or cation. The IUPAC rule for writing any name of the chemical is always the positive, electropositive species first. That is, you will find the positive species first, followed by negative species like sodium chloride. Any molecule, take the positive, less electropositive element is written first, followed by the more electronegative element. Here, let us identify this complex. So the complex identity is written here first. That means we are talking about a cationic complex. Okay. So when it goes into the water, CR, NH3, whole thrice, H2O, whole thrice, square bracket, complex entity. And what will be the charge here? Now, since the charge of fluoride is here, the combining capacity here 3 is of a complex that will go at 3 plus and Cl1 minus. This is how the crisscross method studied in grade 9. You remember? Okay, can I have this complex? So first of all, identify the oxidation state of chromium. Amine ligand is neutral, water is neutral. Chromium will behave, chromium will have the oxidation state plus 3. Yes. So how we will write that? So we have chromium 3 chloride. We don't have to number the chlorine here, chloride, because this plus oxidation state of the chromium will satisfy the number of chloride. Now we have 3 amine group. Okay, can write 3 triamine, and triaqua. Now, guys, there should not be any space between the names. Do not leave any space in the entire name. In IUPAC name, there is no space. Okay. What if you write triaqua first and write triamine? Say, for example, triaqua, triamine, chromium 3 chloride. Then we have to remember that the ligands should be written in the alphabetical order. So both the ligands starts here with A, then we'll go with the M. So M comes before Q. That is why we have selected amine first alphabetically. Okay, so triamine, triaqua, chromium 3 chloride is the name of this complex. Let us go with another name. Okay, what will be the name of this? Again, identify this first rule, identify the cationic or anionic complex. My complex entity is written first, that means it is a cationic complex. Cationic complex, the metal is not renamed, it remains as it is. So let me write platinum. Platinum. Second step is the oxidation state of platinum. Amine is 0, fluorine is -1. Because there are Br3 minus, definitely this complex will be having positive 3 charge. That is why 3 bromide ions are attached with this positive 3 charge. So what will be the oxidation state of platinum? Let's calculate. X plus 0 times 5 plus -1. So I'm adding X, 5 times 0 and 1 times minus. And what is that? Equal to the charge on the complex. Charge the complex, that is 3 positive. 0 minus 1 goes to the right hand side, becomes +1. The answer is +4. The oxidation state here of platinum is +4. That is right as a Roman number. Bromide. So bromide. Now let us talk about the ligands. We have two ligands. Pentaamine starts with A, chlorido starts with C. So the name of the compound complex will be pentaamine. Pentaamine. Remember the 2 times A will come. Okay, penta and amine. So pentaamine. How many chloro? 1 chloro. Okay. So monochlorido. If we do not write mono, it is understood we are talking about only 1 chloro. Okay. So pentaamine chlorido, monochlorido, right? Chlorido, platinum 4 bromide. So one entire name without any space we have to write. Pentaamine chlorido, platinum of 4 I. This is the complete. Another example. Again, look at here, platinum, cationic example. Okay, that will be positive 2 charge of the complex because chlorine is 2. This comes from the charge from the coordinate complex end. So here the ligand is ethylene diamine. Remember, there are 2 ethylene diamine. So it will be bis. Bis ethylene diamine. I have to write a complete name. Okay, bis ethylene diamine dichloro. Dichloro. Why dichloro written to be? Because dichloro start chlorido. Dichlorido. Chlorido starts from C. Amine starts ethylene diamine starts with E. So C should come first alphabetically. So we'll write dichlorido. So there is a spelling error here. We can change it. Dichlorido. Change from dichloro. Dichlorido. This ethylene diamine. More M will come here. Diamine platinum 4 chloride. Okay. Why we have written here chloro? Okay. So these are the old conventions. Fluoro. Okay. What if you write by mistake chloro? Because still you will find many reference books where these old names are still published, like chloro. Instead of chlorido, they are still writing chloro. Okay. So what if you write this chloro instead of chlorido? Most probably in the board exams, CBSE board exams, uh, deduction of marks might not be there. But when we know that there are new sign conventions, there are new rules according to IUPAC has already came. Okay, so you better write Florido instead of writing Floro. Okay, but yes, the correction goes student-friendly method. So marks mostly will get awarded. Oh, now let us go with the next. Again, this is the cationic complex. Ethylene diamine. Again, how many are there? There are three. So for three ethylene diamine, we will use word tris. So the name is tris ethylene diamine. Tris ethylene diamine cobalt. What will be charged on the cobalt? Cobalt is three. Come from here. The two, one sulfate. Okay, that is fine. Ethylene diamine is a neutral ligand, so there is no oxidation state for the ethylene diamine. So whatever the charge on the complex entity will come purely belongs to cobalt. Right? This ethylene diamine cobalt 3 sulfate. This is the name of the coordinate max. Now we have a anionic complex. Okay, why this is anionic complex? Because first we write cation, and this second part, which is a complex T, is a negative. So this 4 comes from T here. Okay, potassium will have +1 charge. So here in this case, we will write the positive part first. In previous examples also, we have written the cationic part first, followed by the anionic part. So here potassium is the uh, cationic part. So let us write potassium. Now let us come to the meaning of this complex. Hexa. Hexa means 6. Cyanido. Here means cyanido. F. What is the oxidation state of iron? Let us calculate. Fe. Don't know the charge on it. Oxidation state on it. Cn -1 oxidation state. There are 6. Overall charge on this complex is negative. So x plus 6 times -1 is equal to -4. This we are doing. -6 -4 become plus 2 is the oxidation state of the iron. We will write potassium hexacyanide two. Hexacyanide 2. Why 8? Because the iron is in the anionic part. Again, let us talk about this another anionic complex. So this is sodium nickelate chlorido. Okay, so we have uh, sodium tetrachlorido nickelate. Nickelate, what will be the oxidation state of nickel? Let us calculate that first. Sodium has here 2, so this 2 has came from the negative part of the entity, complex entity. So we can have nickel Cl4 complex 2 minus. So x plus 4 times chlorine -1 oxidation state is equal to the total charge on the complex, that is 2 minus. So -4 and -2 will become +2. Nickel has here +2 oxidation state. So what will be the name of this compound now? Compound's name will be sodium tetrachlorido nickelate, Roman number 2. This is the name of the complex. Fine. Now try this question from your own side. Okay. try this. Platinum is here cationic part. Okay, first write the name of amine. How many amine group are there? Two. So diamine. Okay, now here there is no complex entity, so we will write fluorine. Fluorido also a part of a ligand, so we'll write diamine tetrafluorido platinum. Okay, and same way you have to calculate the oxidation state. That will be plus 4. So the name will become diamine. Different type of complex you can say here. Okay, diamine tetrafluorido platinum 4. Right, like this is the name of the compound. See, again, this example is many times asked in the board exam. Okay, what is the oxidation state of iron here? Okay, remember the carbonyl compound in a carbonyl complexes, metal has zero oxidation state. Okay, remember this is a very important question. Okay, given in the book also. Here we have pentacarbonyl. Penta means 5, carbonyl, your group, iron 3 because it is not a negative or anionic complex. Okay, so I have write iron in the bracket Roman number 0. So oxidation state of iron here is 0. Right. Now, how this complex has formed then? If iron is not giving any electron, okay, then how does this compound is formed? So this is a classical example of back bonding. Okay, this is a classical example of a back bonding or coordinate bond formed by carbonyl group with the empty d orbital of metal. So in metal, we have an empty d orbital. There is an empty d orbital in the metal, and there is a carbonyl CO group. Okay, which has an electron to give. So this electron goes into the empty orbital of the d orbital of the metal. So this gives a back bonding. The concept is back bonding. Usually this question is asked in the exam, that explain the metal carbonyl bonding. Okay. Now let us try the next question here. Bye bye one. Okay, so the name of this compound again, this is a an ionic complex. Okay, so first we'll write the cation part, that is ammonium. We'll not write diamine here because ammonium, NH4 is a ammonium. Okay, and don't have to write di or tri. It will get the numbers is understood by the charge over the entity, complex entity. Okay, so the complex entity will be having, because ammonium ion is positive 1, so there will be 2 negative charge on the complex. Oxalate, each oxalate is having -2 oxidation state. Water has 0 oxidation state. It's a neutral ligand. So the X, we calculate X. What will be the answer? X plus 2 times -2, that is we have 2 oxalate ion, plus 0, 2 times 0, oxidation state of water is 0, is equal to 2 minus. So this -4 and -2 will become +2. So nickel has oxidation state as +2. So the name of this compound will be ammonium diaqua bis. Okay. oxalato, nickelate. Now this is also a why here now this oxalato says, for example, metal oxalato. Okay, define what that is. Wait. This type of ring structure will form. Okay, so for that we will be using this. Ethylene diamine also has a ring structure. Ethylene diamine also has a ring structure. N C N. Once the ring structure is formed, a polydentate, bidentate ligand is there. We will use the word bis. Okay, so oxalato is also making a ring structure, acrylate. So we are writing here bis oxalato nickelate. Nickelate because it is present in the negative uh, part of the complex nickelate 2. Okay, now write the name of this last compound. These all are variety of the questions. Okay, the first part is cation, second part is anion. First part silver will be called as a silver only. Second part silver will be called as a argentate. Okay, metal ending with 8, and if there is a Latin name for that metal, we'll write this. So argentum is the Latin name of the silver. We'll write argentate. So first I will write diamine. Let's talk about the cationic part. Diamine, silver. Here is oxidation state of silver is +1. Silver 1. Dicyanide, argentate 1 +1. This will be the name of the complex. Diamine, silver 1, dicyanide, argentate 2. This is how we have to name the compound. Okay. Okay. For practice, you can have these examples. Okay. You can click the photo of these questions. Answers to this are given below. Okay. You can take a screenshot of this for a practice. Right. That is a small fast recap of this chapter. We have studied the Werner theory, which is talking about the primary and secondary valencies. Primary valencies are ionizable, secondary valencies are not. Secondary valencies are fulfilled by the empty d orbitals of the metal. Okay, and hence they form a complex entity along with the metal. Secondary valency, the ligand and the metal defines the structure of the complex, like tetrahedral, octahedral, square planar, like that. A difference between double salt and complex is already we studied in the last previous class. One question may be there because this question has been asked in the board. Give a difference between double salt and the complex compound. Few definitions which are not actually asked in the board exams, but without this terms or names or these terms, we cannot be able to give the proper answers. So you should know these terms, go through this. Okay, polydentate ligand, EDTA. The full form of EDTA has been asked in the board exams several times. So remember that this is ethylene diamine tetraacetate, EDTA. Okay, what are chelates? Chelate is again a very important question which has been asked in the board exam. Denticity again not much important, but we should know that monodentate, didentate. Okay, ambidentate ligands is frequently asked question. Ambidentate. Okay, more than one donor site in the same ligand. These are the two classical examples we studied last class. Ordination number, heteroleptic and homoleptic. If all the ligands are same, we call it homoleptic. If the ligands are of different types, say for example amine and chlorine here, they are known as a heteroleptic. Nomenclature, a very important topic of this chapter. Okay, we have done just today with several examples. So these are two examples in the book. There are in-text questions. Go through it. Okay. The names will remain the simple. They will not ask very complicated names. So in-text question and the exercise part of the chapters for IUPAC names is enough, quite enough. Okay. Isomers we have done in the previous class. There are few good questions in the in-text. VBT we have done yesterday. There are 4 examples in the VBT in the book which are very, very important. Okay. There is no new complex which board will ask in VBT. There are 4 examples, set examples in the book. Okay. Here you will find the hexamine cobalt. Okay. And you have hexafluoridocobaltate. Okay. So these are common examples. Every time the similar example, same example, not even similar, same examples are asked under the name of VBT, or what are high spin complex, what are spin free complex, okay, or inner orbital or low spin complex. Okay, these are the few several names given to this complex. This page which is on your screen right now, and the second page right now on the screen, is worth of at least 2 to 3 marks. Okay, every year one question from this 2 page definitely comes. Okay, so VBT, these 4 examples, okay, you must do for the board exams preparation. Magnetic property we discussed because of the unpaired electron, the formula given under root n into n plus 1 question. Okay, there limitation of VBT we discussed, crystal field theory, CFT we did, splitting of d orbital when the ligand approaches the central metal atom. Okay, the direction of the ligand from which it is approaching the metal depends. Okay, is highly important whether there will be splitting, octahedral splitting or tetrahedral splitting will be there. The same diagram, okay, same diagram we have to draw in the exam to show the splitting of d orbital. This splitting of d orbitals in T2G and EG sets actually responsible for D to D transition. This is how the electron moves from this pair to this pair. Okay, this set of orbitals to the another set of it. So this is D to D transition, which is responsible for the color of the complex compound. So this question, this conditions, okay, was asked in last year's board exam. Okay, go through these conditions. What will happen if the delta O, the difference in the energy of EG and T2G is more than the pairing energy? P stands here for the pairing energy. What will happen? Okay, what if delta 0, delta naught is smaller than P? What if the delta naught is bigger than P? So both the splitting you have to explain. Okay, and again it is asked in the board exam. Okay, same answer but different way of asking the question. This is another splitting, the same. Why the complex are colorful? We just discussed that there is a D to B transition is there. So in doing so, they absorb the frequency, certain frequencies are available from the sunlight. Okay, and the few frequencies are not absorbed. So the one which are absorbed does not get reflected back. The one which are reflected back imparts that color in the complex. So for example, copper sulfate, okay, hexahydrate, if you see, the blue color is reflected by the copper sulfate, hydrated copper sulfate. That's why that complex looks blue in color. This is the mechanism how the energy is released by the compounds. Bonding, metal bonding, which is discussed today, is a back bonding. Okay, These are the empty d orbitals of the metal, and these are the p orbitals of the carbon, oxygen, where there is the electrons are there. These electrons are donated to the metal, and metal gives its electron to the empty p orbital of the carbon. That is what we call as a metal carbonyl or metal back bonding or synergic bonding. This question is asked frequently in the board exams. Importance and application of coordination compounds. PDTA, it is used for softening the hard water. We know many complexes that hemoglobin, the blood, red blood cell is a complex. Chlorophyll, green pigment of plant, which makes food, is a complex compounds. There are many complex compounds around us. All your vitamin Bs, okay, vitamins, they are complex compounds. So this is how we, this is what this chapter is all about. A very scoring chapter, okay. Easy topics are there. Direct questions are asked from this chapter. There is no much experiments done in asking the questions. Direct questions are there and direct answers are expected from the students in the board examination. So far, any doubt? No doubts, no chat section. There's no question. Fine. So you must give one entire day to complete this chapter. Okay. IUPAC names are also important. Okay, for the preparation of the board exam for each chapter, students, you must make a list of the questions, or you must have the questions which have been asked in the board exams previously. So these are the few questions year wise which were asked in the sets by the CBSE. These are the questions. 2020, 2019. During those years, like 2020, the pink highlighted questions were deleted from the syllabus. So there are some deletion in the syllabus also. So according to the syllabus, you can go through with the preparation. Using IUPAC norm, write the formula of the following compound. So 2 questions, 2 marks, direct question. Chelate complex, what are chelate complex, what are ambiguous ligands? Okay, write the IUPAC names. Formula from the name, see, from the name, you have to write the formula. Direct 2 mark questions are there. This is what we were just talking today, that if difference in the energy of T2 in EG is delta naught, smaller than the pairing energy, then what will happen? The same question, direct question from the book, NCERT. For this chapter, 100% we have to rely on the textbook, NCERT textbook. No need to take any reference book. Polydentate ligands, what are homolaptic complex, that we did. IUPAC names of this compound, again, see, from the name we have been asked to form the formula. Okay, again the similar question, 2019, different sets. 2018, write the coordination number of this ethylene diamine, 2 plus 2, 4 plus 2, 6. Answer here is 6 coordination number. So 1 marker question, either in the form of an MCQ or direct questions will be there. A, B, C type, 3 mark questions again here. IUPAC names again, you have to write the formula for it. Nitrito N stands here that nitrito NO2 Ligand is connecting itself with nitrogen and platinum. It is not the oxygen which is combining with the platinum, it is a nitrogen. So we have discussed this yesterday also. Okay, the 2007, some questions are there. So likewise, you can have any nice reference book and year-wise questions you can segregate out of it. Okay, or this type of question bank you can get it from ETL. Okay, uh, there you can get these all questions you can download, okay, from the question bank or from the worksheet of the assignment bank. Okay, you can do this. So there is no doubt. Let us wind up the session. Okay, it was nice session with all of you. God bless you and work hard, practice well for the coming board exams and its other entrance exams as well. Thank you.